And we are live. Welcome everyone. My name is Daniel and I will be the host of this session. We are Technical Excellence, Tech Excellence. Our vision is to raise the bar of technical excellence across the world. Here are our organizers. First and foremost, Valentina Cupac, our founder and organizer. Next to her, we have Alina Liburkina. She is also a co-organizer of these events. Next to her, we have Oliver Ziller, another co-organizer and the secondary host of today. And last but not least, me, Daniel Moka, another co-organizer. Here are our speakers of this year. Some of them we already had. We had really exciting and informative sessions. They are all recorded, so they can be found in YouTube. And of course, we have great and amazing session planned for the following weeks, so stay tuned. We are available online, of course. First of all, website techexcellence.io, but you can also follow us on Meetup, YouTube, LinkedIn, Twitter, GitHub, and last but not least on Discord. We have a vibrant and active community there, so feel free to join us. It's free, and we have great conversations there about talking technical excellence. Many thanks, big thanks to our sponsors, Optivem, and to our partner, QE Unit. Learn how to deliver quality software faster with us. Let me introduce the speaker of today. His name is Kyle Aretae. He's a software developer, technical trainer, and agile coach. Lately, he's in an agile coaching leadership role, focusing on organizational change. And the topic of today, we could not have better topic today than talking about technical excellence in a technical excellence meetup. So the title of his speak is "What is Technical Excellence and Who Cares?" Welcome, Kyle. It's a pleasure to have you. Before I hand over the microphone, I would like to remind everyone that if you have any question about the session of Kyle, then feel free to ask it in the YouTube comment sections. And at the end of his talk, we are going to dedicate half an hour to talk about all the questions you have. So feel free. Basically, that's it. So Kyle, thanks again. The microphone is yours. I wish you good luck. We're looking forward.
Thank you. And there are my slides. Wonderful. Thank you. Okay, here's our topic. Thank you for joining us. The topic is technical excellence, who cares, or so what? There's a lot of us who talk about technical excellence. I believe many of the folks on this presentation have done it before. We talk technical excellence. We say, hey, this is good. This is better software. This is excellent. This is clean code. This is good architecture. We say a lot of things about that. When we say that, though, what do we mean? First question, I would love it if you would throw some of your ideas into the comments while we're going through this. Having said that, I'm going to give some answers because it's easier if I start talking. Yay, there's comments. What is technical excellence? I have heard people say, hey, technical excellence is when the code is well written. I've heard people say, hey, technical excellence is when we have some tests in the code. Technical excellence is, I don't know, we have security. Some people will argue, hey, that's a side issue for technical excellence. Some people will say, oh, it's architected well. Technical excellence would say, there's a lot of options for this. But yes, please, thank you. During the comments, you can see the comments are being written. So there are a lot of people who talk about technical excellence. One of the problems we have, though, is that when we're talking technical excellence, it's not always communicating to some of the people that matter. Question number 2, what is the goal of business? Well, the goal of business is pretty universally to make money. Sure, there are nonprofits. Nonprofits exist to pursue the goals that their donors want. Governments, organizations exist to pursue the goals that that the politicians would like them to pursue. However, for most business, we're dealing with profit motives, and most of what the business is trying to do is make money. Okay, Kyle, that's great. How does this have to do with technical excellence? Well, that starts to be where the problem comes in. Software is not, for most problems, the hero in the story. We're the sidekick. We're the support. We are Alfred to the business's Batman. Batman is trying to get something done, and Alfred is making it possible for the business to get something done. Or we're a minion to Gru, if you like those shows better. Or Peppa Potts, but I couldn't find any non-copyrighted images for Pepper Potts, so I got Gru as Gru's minion. We are support. We help the business do what the business is trying to do. Sometimes we are the product that is the business is trying to sell, but the fact is the business tends to be primary, and we in software tend to be secondary, and this makes for some interesting communication. It makes for some interesting problems. Let's look a little bit at those. What does a business need from technology? Well, it's pretty simple. I have actually written out, hey, here's 5 different things a technology organization can do for a business. I've written it as 7, I've written it as 5. My friends these days are pushing me to be much simpler, and so they're saying, hey, look, there's 2 things we can do in technology for a business. We can make the income go up, we can make the expenses go down. That is pretty much the range of what we as a technology organization can do to support the primary organization, which is mostly about making money. How do we make income go up? Well, maybe we have a system and we can make it so more people buy the things. I've seen recent cases where we've changed features and we've lost drop-offs. So people were signing up for a service and then they would stop in the middle of signing up for the service. And by changing our websites, we were able to decrease the extent to which people stopped signing up. So guess what? That meant our income went up. That's great. We have the ability to make incomes go up. Maybe instead we can decrease expenses. An awful lot of what IT does, even though it's not the nicest thing to say, a lot of what we do is we save stupid repetitive work from people who might not really want to do the stupid repetitive work. And so what we do a lot of the time, I have spent a lot of my career in building software that handles customer service. I've worked for building software that makes the customer service work better. Maybe that makes the income go up. And I've also built a lot of software that makes the customer service less necessary because you can self-serve on the website. In reality, when you say we are making customer service less necessary, that means that when people quit a customer service job, we don't rehire somebody else, and so the expenses go down. Software can provide two pieces of value for business. We can make the income go up, or we can make the expenses go down. As software people, sometimes we don't take this basic truth seriously enough, and it limits our ability to talk to people, particularly the people in the business who pay our bills. One of my favorite things to talk about ever is the Claude Shannon communication model. Shannon was the 1950s engineer who designed a communication model that basically ended up being the foundation for how we think about network communication and how computers talk to each other. But it turns out the communication model is very, very powerful and helps us to understand human communication as well. The communication model from Shannon is there is a sender who has a notion. So this model doesn't have the whole picture. The sender has content that they want to send. The sender then takes the content and packages it into a message. They encode the information so that the information can be sent. Then they pass that encoded message along a channel, right? There is some method of communication. And then that message in the channel encounters noise. The message is imperfectly transmitted. In this case, I like the analogy of listening to somebody speak, like say you're listening to me talk right now. In reality, when we talk, the way things work is I say words that I mean to say. For instance, I might say the word bee, like a little buzzing insect. And when the message goes through noise, maybe my microphone isn't perfect, or your speakers aren't perfect, or there's background noise or something. The message gets to you, and what you hear is some sort of sound followed by E. And what in practice you have to do, this is actually part of the audio cortex of your brain. What your brain does is it hears E without the clear B at the beginning, and it guesses from context clues what I said, and then it hands you the information about what I said. So I say, the bee is buzzing, and you hear E and uz, and you go, oh, uz and E, guess we're talking about a bee. And so what you actually hear is the bee is buzzing. Or maybe you hear the tree is fuzzy. This is all pre-processing done by your brain before it gets to your conscious mind. Interestingly, this is a good reason why people mishear each other, and also it's used very useful if you are talking to a spouse or a boyfriend or girlfriend, and they say, hey, did you hear what I said? And you can say something, and even if you didn't hear, your brain is actually doing a lot of the processing before it gets to you, and a reasonable chunk of mishearings where the sender intended to send one message and the receiver received a different message is actually pre-processing by the brain. It's loads of fun. My favorite part of the Shannon communication model is not that, it's the fact that Shannon doesn't count it as communication at all until there is a feedback system in place. First, the receiver receives the message, and maybe the receiver receives the message fuzzy tree, and then the receiver responds with feedback, which also has to be encoded. They have an content, they encode it, they send it to a message, it gets inhibited by the noise, and it gets to the sender decodes it. So I say buzzing bee, you hear fuzzy tree, you say, I don't think the tree's that fuzzy. And then we can actually have, that is the first time real communication has happened, when I have sent a message and then I have received that you got the message. So what does that have to do with good with technical excellence? Well, I have it on the slides. Most of the time, when I talk to business people and I say words like better code, technically excellent, elegant, good architecture, words like that, when I listen to the response from the receiver, what they are hearing is, you want to spend time to make it more expensive without a clear business benefit to me. That is what is heard in my experience, plus I've been consulting for a long time. I've been traveling the world for 25, 30 years, wandering around, talking to people about code and how to write code better. And the almost universal response is this one. You say better code, I hear more expensive. Where are my dollars? Where is the financial benefit to this business from doing better code? Here's the problem. Communication problems can be interesting. They can be a great topic. I personally get excited about how communication fails, and it's lovely, and it's a fascinating intellectual exercise. But the business folks who we're talking to, they pay our bills. They say, hey, can you do some stuff for me? And then they give us money. And the fact that they're giving us money means that we have something of a responsibility to figure out how to communicate to them. In some cases, in personal relationships, miscommunication is a problem that is both sides' problem. It's clear that it's both sides' problem because both sides would be unhappy if the other person walked away, if they left. In the case of an employment relationship, in the case of business working with technology, it is not a peer-to-peer communication. They run a business, they have money, they pay us. We help them achieve their goals because, as before, we're a support organization. Since they have the money, they have the power, they have the status, however you want to say it, it is now our technologist responsibility to communicate effectively to them so that they know what their benefit is from doing things well in a technically excellent fashion. This isn't pleasant for me to say. It feels kind of bad. It's like, hey, we're second class. Well, in the business world, they would rather not have to deal with this. What business folks want is a way to make money, and we are suggesting to them that we can help them with that. It's our responsibility to communicate better. It is not their responsibility to understand better. Coming back to communication, this is like my favorite. Wiio's laws are a sequence of laws. A gentleman who was an academic, and then he was part of parliament, I think in Finland, but I'm not sure. His name was Wiio. His last name was Wiio. And he created a bunch of semi-humorous laws talking about how communication fails. Wiio's first law is that communication usually fails except by accident, and we have to deal with it. Well, that's not his law. We are going to fail in communications, and so we need to work better, harder, more thoughtfully to do this. And I already said this. This is actually one of my favoritist jokes. Goes something like this. Once upon a time, there were two people speaking together on the radio. There were some Americans and there were some Canadians. I'm an American, by the way. The Americans say, please divert your course 15 degrees to the north to avoid a collision. The Canadians say, recommend you divert your course 15 degrees to the south to avoid a collision. Americans, this is the captain of a United States Navy ship. Again, I say, divert your course. Canadians, no, I say again, divert your course. The Americans, this is the aircraft carrier, USS Lincoln, the second largest ship in the United States Atlantic Fleet. We are accompanied by 3 destroyers, 3 cruisers, and numerous support vessels. I demand that you change your course 15 degrees north. That's 15 degrees north, or countermeasures will be taken to ensure the safety of this ship. The Canadians' response, this is a lighthouse, your call. I tend to think it's funny. The question is, whose problem is it to change course? A lot of us in the technology space know a lot about how to build software well, effectively, and in a way that's good for the business. And the business people have the money. In this example, the business people are the lighthouse. Doesn't matter how good we are. We don't want to get into a case where we run into the lighthouse. So as technologists, we're the folks who need to change. Okay, I've laid out a problem. The problem is, I go about my business and I say, hey, look, we want to do technically excellent stuff. It's super important. It's a big deal. Technical excellence matters. And business says, okay, you want to spend more money writing code. How does that benefit me? How do we get to more income or lower expenses from this question of technical excellence? Because it sounds to me like you just want to spend more money. On top of that being the foundational problem, we have a second problem of asymmetry. We as the tech folks are support. They are higher status. They are in control. They have control of the purse strings. We have to do the communication. We can't expect them to come to us for communication because they're asking for something specific. And if we want something different, we are the folks who have to do the persuasion. And as you may know, as you have mostly probably experienced, not every business person in the world is excited about spending extra money for technical excellence. So let's restate the problem in very simple words. Some people, us, are interested in clean, in good code, in technical excellence, but the first book that, not the first book, the most popular book that said it clearly was Clean Code. And so the clean image is there. The business folks are interested in, how does this make me money? That's the problem. That's the whole problem. What are we going to do to get to alignment? If the business is the blue line, we're the purple line, we have to do some amount of communication clarity. We also may have to do some amount of changing direction. The other thing you hear loudly from business when we talk about technical excellence, you hear that, hey, those technical folks, they just want to go around and play in the code and make it pretty, make it beautiful, make it elegant, make it clean. Some of the things we want to do are probably of financial value to the business. We should be able to talk about those. However, we should also be willing to talk about the fact that maybe not everything we want to do is really a financial win for the business. And so our issue is not just how do we communicate better. The other side of our issue is, are we actually serving the needs of the business with all of our technical excellence desires, or are we serving them with 50% or 80% or 90%? If we are going to work with businesses towards technical excellence, not only do we have to communicate better, we may have to shift some of our positions on what counts in terms of technical excellence, how we go about this, because some things we would think of as technical excellence are not a dollar value to the business, and they maybe even correctly don't want to pay for it. We need alignment. We need perhaps to change some of our positions on technical excellence, not just to communicate better. So my recent rounds of thinking in agility and technical excellence, the things I focus on most right now, I focus on goals, and I focus on what I call the domain. And another way to say the domain is, what is true about doing software development? Or what is true about working together? And so I want to call attention to a couple of these things that I refer to as universal truths. They're the ones I focus on most in my communications. Here we are. Number one, we're wrong a lot. If we've spent a lot of time in folks who like to watch sports, if you watch basketball players, shot percentages hover near 50%. If you shoot a basketball, there's about a 50%, well, if a professional basketball player shoots a basketball, there's about a 50% chance it goes in. That makes for really, really high-end NBA shooters. They can get the ball in the basket one time and two. And so they miss one time and two. For American baseball, the best players in the league get a hit one time in three. For oil well drilling, if you go looking for new oil wells, people spend $5 or $10 million trying to build a new oil well. And if you're going and drilling someplace that isn't perfectly well known, success rates are 10%. In the United States, we have new restaurants start up. There's a 90% failure rate over 5 years. Startups in the organization fail at 90% or so in 5 years. new features in software? Well, guess what? When I have done surveys of folks and found people who collect data on the topic, they figure that somewhere between 1 in 10 and 1 in 20 software features are positive value for the company that is building them. The rest of them, we built something and they were neutral or net negative. They made the company no money. There are lots of things we want to do, and what we do to do those things is we make a prediction about what the outcome is going to be, and then we try it. And in making our predictions and trying the results, we're wrong a lot. Other smart people have said it differently. Prediction is hard, especially about the future. This matters. A lot of people building software forget about that. Second problem, working together is hard. If you want me to build an individual Android application and with the back end and use all the fun tools for Android, I can do that. I've done that. That's not terribly hard to do that by myself if it's a small project. If I need to work with 3 or 6 or 12 other people, the level of difficulty goes up substantially. It's harder to work together than it is to work by myself. The coordination business, the things that I can hold all of the information about my application in my head, but if I don't even have all of the information, then coordinating starts to get tricky. Third point, software is like a car. In that, in the United States, when I buy a car, a relatively inexpensive new car costs me $20,000. To then run the car and use the car for the next 5 years will cost me $60,000 or $80,000 total dollars. So the purchase price of the car is 20%, maybe 25% of the total cost of ownership of the car. And so anybody purchasing cars would be really stupid not to think about the long-term costs of the car. I was visiting family in Los Angeles recently, and I took an Uber ride, and my Uber driver was driving a Tesla SUV. And he said, look, I did the math. I bought a Tesla SUV because it cost me $2 a day in gas rather than $100 a day in gas. And the costs of running the application, the costs of running my car are so much lower, even though the car itself cost $100,000 as opposed to the other car that I would have gotten, which would have been $50,000. The cost over the long term is much, much lower. When we think about software, that is also true. The cost to keep the software running, maintain it, debug it, make feature changes, update it, keep it running, given that the underlying tech keeps changing. We have to switch versions. Hey, Spring Boot updated, so I have to update my code. We are now using Log4j2, and I have to change some libraries, and it turns out the libraries have shifted, so I have to write the code differently. All of that stuff is stuff you know, but the cost of doing that is higher by a fair margin than the cost of writing the software in the first place, at least when you pay attention to the total cost of ownership over the lifetime of the software. And then the thing that our business partners are harassing us about. TANSTAAFL, famous old line. There ain't no such thing as a free lunch. famous claim from the early years of the 20th century. Essentially, if you're gonna get something, you have to pay for it. If you think you're getting a free lunch, you're paying for it somehow. If somebody gives you higher benefits, like you have better in the United States, employers pay for a lot of healthcare costs. If you have better health insurance, then they pay less salary. The economists have studied it, it's universal. If you're getting a benefit here, you are losing something over there. There is always a cost that's being paid, and we have to take that notion seriously. There's always a cost, there is always a trade-off. What is the trade-off we are making? What is the trade-off we're willing to make? What's the trade-off that we're maybe not seeing? So these are the truths that we're running into along the way of the business wants to make money, and I'd like to write clean code. So how do we talk to the business about clean code? I've stopped using the words clean code in business contexts. I've stopped using the words good architecture. I've stopped using the words technical excellence even. The words I use have become very simple. How much does it cost you to change your code? Number one, I will guarantee you that by the time we sign a document that says, here's what we're going to build for you, the thing you want has changed. 100% of the time, if you say, this is what we're going to build, by the next day, there is something else that they want, and we have learned something about the code. So there is going to be changes. Furthermore, when I build a piece of software, an awful lot of the time, that piece of software sticks around, not for 6 weeks, but for a decade, sometimes 2 decades. I expect that many of the people on this call are having loads of fun dealing with software that was written a decade or 2 or sometimes 5 ago. I've certainly had that joy. If your software sticks around for a decade, then we need to talk about the cost of changes. The cost to build something in the first place is really, really a small percentage of what we actually spend maintaining the software. When I'm talking to business, when I am talking about either increasing value or decreasing expenses, the first place I go is we can decrease total expenses. And we can specifically decrease total expenses because we can make changes cheaper. And there are always enormous numbers of changes. If we stop saying, hey, I want to make this clean, I want to make this technically excellent, I want to make good architecture when we talk to the business, and instead we say, I want to make it cheaper to maintain and run this software, then we have room to have a conversation with business, and then they want to talk to us because, you know what, we are offering to save them money. Caveat, there's a bunch of people who want to talk about the non-functional requirements or the ilities, accessibility, maintainability, blah, blah, blah. Security doesn't quite count as an ility, but it's the same rough thing. Availability. I have a simple claim about the ilities. When I've done security work, the single biggest thing I've learned about security work is that things change. The threats we have today are different than the threats we have tomorrow. And so when we talk about security threats, my single biggest thing to handle security threats is pretty simple. Can I change my code to be, I'm reading the comments as I talk, so I'm pausing occasionally, apologies. Can we change the code quickly enough to address the new security threat? The most recent giant security issue that we all had fun with was Log4j, right? That was the biggest one that ate everybody's lunch. And so the question that we all ran into with Log4j was, hey, there's a new vulnerability. How quickly can we make changes? How cheap is it to make changes to our code to make it so that our software is safe again? Gosh, again, it sounds to me, and yes, I'm selling here on what my position is, but still, it sounds to me like the best way to have future-proof security is to make sure your code is easy to change. Accessibility, we have to pay attention to. If I use red and green as the only way to tell things apart on my website, then folks who are colorblind can't tell the buttons apart. They can't use our site. It's bad for us. In some cases, it's bad for us because the US government finds us and says, hey, you are not taking our disabled folks seriously, so we are going to fine you $100 million. In some cases, it is simply, if we don't provide service for people who are disabled, then we are not getting their business. We need to address those. If you build something and you find out that it is not appropriate for somebody, perhaps you've built a site and you didn't provide an audio alternate for folks who are blind. How do you fix it? Well, the question is, what does it cost to improve it? What does it cost? How fast, how cheap can you make a change? Okay, so I've made my central argument. My central argument is that as technical excellence, we desperately, as folks who are interested in technical excellence, we desperately need to communicate in business terms to business people. Yes, there's cases, this meetup in particular, we need to talk to ourselves, among ourselves, to each other, about how to be technically excellent. But once we start talking outside of our technical groups, we have to shift our language and we have to communicate from a point of view of dollars and cents. My claim is that technical excellence is more or less equal to the statement, I can make changes cheaper in the future. Now, what does that mean? Well, step one, there ain't no such thing as a free lunch. If I'm going to get more of something, I'm going to get less of something else. Let me be super clear here. If I build something that is technically excellent today, I can build something that works for, and I'm making up numbers here, but I don't think they're far off. I can build something today that costs me an hour to build. And it works, but it is not technically excellent. Or I can build the same thing and make it technically excellent. In practice, when I build my unit tests, when I run it through my linter, when I do my mutation testing to confirm that my unit tests are covering everything, when I do TDD, when I do this with a small mob or a pair, every one of those things makes the code a little bit more technically excellent, and it increases the cost by a little bit. So if I can do it by myself in an hour in a quick and dirty fashion, I can build the same thing clean for $200 for in 2 hours. I am trading time today for a percentage of all future changes. Spending 2 hours today versus 1 hour today. If I spend 1 hour today, then every future change costs 0.5% more time, maybe 1% more time. If I do it clean today, then when I do my next thing tomorrow, I'll spend an hour and a minute, or an hour and 3 minutes, or an hour and 6 minutes, instead of spending an hour to do the same thing. What I'm doing is I am preserving the cost of future change. Now, that sounds like a bad trade on first glance. If I'm going to spend twice as much today and I'm only going to buy 1% difference tomorrow, that sounds like a bad idea. Except we make a lot of changes. And Einstein is famous for saying compound interest is the most powerful force in the universe. And what we're talking about here is compound interest. My personal experience, and I would love to hear yours in the comments if you'd like to add, my personal experience is that somewhere between 6 and 12 weeks from now, spending the 2 hours today for instead of 1 hour of unclean work ends up paying off. If I work today and I do a little bit of cleaner code, and tomorrow I do a little bit of cleaner code, it takes somewhere between 6 and 13 weeks before I am better financially than I was before. Yes, it involves spending some money up front to do more cleaning. It involves spending time. But for every decision I make, I am making the decision, am I going to do it cleaner, more expensive today and cheaper tomorrow? Or am I going to do it cheaper today, not clean, and more expensive tomorrow? And my experience is 6 to 13 weeks, 6 weeks to a quarter. That's really the time frame at which I see payoff really happening. So if you have a project that only runs for 6 weeks, like say all student projects, it's of course smarter to do it without doing it clean. But if you're going to do something that sticks around for more than a quarter, the cost differentials end up being kind of huge. I get super excited about this one. I am personally familiar with at least 3 distinct examples where people paying attention to clean code and people not paying attention to clean code were solving the same problem. And the systems lasted for a while. And in each of these cases, people who were really diligent about keeping their code technically excellent ended up having cost of change factors that were on the order of 1,000 times less than other ones. A friend of mine had 3 parallel systems. They were working together. One of the systems was built clean. The other 2 were built quick and dirty. the clean system, the dirty systems were asked, hey, how much to make this change? And they said, well, it will take our team a month to make the change. The clean system got a request for a change. They said, oh yeah, we can do that in 15 minutes. That's the real kind of deltas that you see for cost of change between easy to change systems and hard to change ones. I've seen a different case where, hey, how long does it take your team to do this? Well, we estimate that this change will take us a quarter and a team and $250,000. And you go somewhere else for the same exact system. You go, how long to make this change? And they said, oh yeah, we did it just now. It took me an hour by myself. And I have stock options, so it cost almost like $250. So the delta that you can get, the cost of change is enormous. The delta in cost of change, it can be a factor of 1,000. So what makes for code that is cheap to change? Everybody's got their acronyms. You can use solid if you want. You can use 12-factor if you want. I don't care which acronym you use. I built one and then found out that mine matches fairly well the book that Kent Beck wrote in 1996, Patterns in Smalltalk. And so I like this example. When I say what makes for code that is cheap to change, I make for a really simple argument. Code should be dusted. It should be decoupled. It should be understandable. It should be in small pieces, and it should be tested. Decoupled. Pull the pieces that are different apart from each other. Leave them isolated, and in particular, decoupled has a really well-known definition, and as technical excellence folks, we should know that. Something is decoupled if, when you make a change to part A, it doesn't impact part B. You don't have to also change part B. That's what decoupled components are. Very simple. It took me like a decade to get used to that definition of decoupled, but I really like it these days. Code should be, let me go back. When I say code is decoupled, how does that make things cheaper to change? Well, very simple answer. The problem in software change is the ripple effect. If I change this, what else changes on accident? What else do I have to keep up with? Decoupling is the fundamental method of thinking that solves the central problem in the software. The central problem in software is if I change A, B might break. And if you have limited the ripple effects, if you have said this piece is isolated, if I change A, it doesn't change B, then B doesn't need to change, then we can still run the code without worrying about B, then I have removed literally 90+% of the danger in building software, the danger in changing software. Understandable. Here's the deal. Humans change code. We spend as much time reading and understanding the code as we do writing changes to the code. If what you want is code that is changeable, number one, this is actually my number one point, number one on your list of things that make code cheap to change is things that make code easy for the human beings that will change the code to understand. I will give up dry, I will give up decoupling, I will give up testing if it helps me make stuff more understandable. Understandability, the human ability to understand what the code is doing, is the single biggest factor in making code cheap to change. I've spent a lot of time tinkering with what I wanted my S to be. Currently, I'm saying small. I've said it for 5 years now, I think. Small chunks of code are easy to change, particularly if they are small decoupled chunks of code. Big chunks of code are hard to change because the bigger the chunk of code, the more cross impacts they have inside the chunk of code. You should make your code in small pieces. What pieces are we talking about, Kyle? Are we talking about functions? Are we talking about classes? Are we talking about sections of functions? Are we talking about packages? The answer is yes. Code that is built in small pieces and decoupled and then communicates with each other is easier to change than code that is not. If you're talking about making the class smaller, yes. If you're talking about fewer methods, yes. If you're talking about each method being fewer lines of code, yes. Small matters a lot. It impacts understandability. It impacts how easy it is to make the pieces decoupled. It impacts pretty much everything. At this point, I'm talking about small changes, small commits, small may be where most of my attention in software goes these days. Am I building something that's small enough? Am I building something, am I making changes that are each small, etc. And finally, tested. When I make a change, do enough things run to check if I broke anything else? Legitimately, this is my hand-wavy term for effectively the entire field of DevOps. When I build code, I check in my code, and then my linter runs. And my linter goes ahead and checks if I've done anything stupid, like, I don't know, return in a finally block is my favorite linting tool. It checks to see if I'm not being attentive to things that matter, like small. Hey, do you have any methods that are over 10 lines of code? Well, my linter blocks those. Then it runs my unit tests. Then it runs my mutation test to make sure that my unit tests are any good, because normal coverage kind of stinks. Then I run, then I do a build, and I spin up an environment, and then I push to the environment, and I run some integration tests. And maybe I run some security tests, and maybe I run some performance tests. And then eventually I've run enough of my tests, and then I go ahead and do my automatic blue-green deploy, where I kick over and I move the URL from pointing to my old version to my new version. How many tests do you have in place to check that your code didn't break, that your changes didn't break anything that was currently working? If you don't have enough, then your code is not safe and easy to change. I'm going to come back to this slide maybe after I'm done talking. My claim, every one of these things is a push in the direction of making software cheaper and easier to change. Right? Whether it be patterns, which Kent Becker introduced to the OO world in 1987, or whether it be hexagonal architecture, which is the newest of these topics, though it doesn't far off miss what we did in the old days. It's all pointing at stuff that makes software cheaper to change. So 3 points. 1, we are responsible for selling the idea of technical excellence. If we're going to sell the idea of technical excellence to business folks, that means we have to attend to how to sell to them. My best sale over the last 25 years of obsessing on this topic is how much does it cost to make a change? And then I have my favorite acronym, DUST, for how do you make it cheap to make changes? Thank you.
What a great presentation. Thank you very much, Kyle. Oh my God, this was deep, very deep. I love that. I have two highlights. First of all, this lighthouse joke about changing the course. I think that was one of the main highlights of this talk, that we try to fail to communicate, right? I think it's one of the biggest issue in our industry, that we really fail with communication, and that is the root cause of many problems. And here there is a great, incredible quote from Woody Zeil. Woody Zeil is the inventor of mob programming, and he said a few weeks ago on social media that let's stop trying to communicate, instead let's collaborate. And he's damn right with this, that instead of, I don't know, sending emails, sending messages, or trying to communicate via PR reviews, we should sit together in a mob or in a pair programming. We should have the customer on site, and we should try to collaborate. So I love that.
I am fortunate right now to be working with Llewellyn Falco. He works with me in the day job, and he's another one of the mob players.
Incredible. Yeah, that's a great practice. And another point is what I really enjoyed and resonated with is that there is no trade-off between quality and speed. It's a sort of illusion, right? I mean, we can sacrifice quality for speed, but it works only for a very short amount of time. But in the long term, we can only lose by not writing clean code, right? As you said, after a few weeks, a coder surely we lose. So I love that. Great job. We have a few points. Let's go through them, I would say, and let's discuss those points from the audience. First of all, we have something from us, but I think this was also another highlight of this session, namely let me remove this. Yeah. So we wrote, this is a winning argument focusing on cost of change rather than clean code. So I think that was the main, I don't know, maybe you could elaborate again about this, or what is your experience with this, or this is the only thing you use instead of clean code, or there are some other wordings?
I really do. I have given up in business conversations. When I'm talking to y'all, right? We're tech folks here. We can talk clean code. We can talk hexagonal architecture. We can talk about whether factory method or abstract factory is a better use of a pattern in this particular case. I'm happy to have those conversations, right? But when I'm talking to business users, every time I say clean, every time I say elegant, every time I say good architecture, they see scary dollar signs and what they're going to have to spend.
True.
That's my experience. Maybe other people have different experience, but that's what I do. And so, I don't know, 5 or 10 years ago, I just stopped saying those words, right? I only talk about cost of change when I'm talking to business. And it seems to be a more effective discussion, but substantially. On the other hand, it means that I have to take that seriously now when I talk even to myself. I say, hey, this is good architecture. Do I really think that's going to make it cheaper to change the code? And so my entire approach to thinking about what makes good code has also updated because of that business reality communication.
Fascinating. I should use this more often, definitely.
I tried it as well. Several years ago, back when I was working as part of a regular company, and I would just use the word budget as the So when we were discussing different, for example, requirements and different possibilities, and when I could see that it was really starting to become too creative and building a castle, I could say, okay, I understand. Okay, what you want is this. Now we could have do it in a different way, like even different concept for requirements, and it would cost 10 times less. The argument ended right there. So So that's an argument. The cost argument can be used both if you want to simplify requirements to something that's like actually necessary rather than building castles. And for the other thing, avoiding clean code, but it's like, let's make a solution such that we minimize cost of change.
But I have to say, for me, it was usually somehow the other way around. I mean, business was usually very happy when I argued with, well, we make it cleaner and then we make it cheaper. But when I go to some devs and I say, let's do clean code, they're like, oh no, Uncle Bob, I don't like him, and then the discussion was over, and they don't want to do that. Or I try to show them, look, this is how refactoring works. Take out the method with your IDE, and they're like, try it out, and then switch to manual refactoring again, and somehow I just don't get it through, and it seems like business is like, yeah, do that, and developers are like, yeah, no.
I've run into that some also. My experience is that if you're a superhero like Llewellyn, maybe you can change minds in a couple weeks. My experience is it takes somewhere, but again, it takes on the order of 6 weeks to actually shift people. If we start writing code together and you're mad at me, but we write code decently for 6 weeks, by the end of it, it's better for you. You can feel the ease of it, and you've broken through your habit traps. But look, I went to college. I did code in college. In college, the job is how long does it take to get the code out the door? It has nothing to do with cost of maintenance. Mm-hmm. And so I built years of habit. Mm-hmm. And I had a bunch of group projects where some jerk wanted me to do all of the work and say we were working together. Right? And so I got a lot of habits to get through to go on that. And so my experience, it takes, look, this is going to suck for you at first. You're not going to like it. In 6 weeks, I can guarantee you it will be better for you, the developer. Mm-hmm. And if you don't want to continue doing this after 6 or 8 weeks, I'll shut up. Deal? Right? That's really how I play it.
Mm-hmm. But this is a really important point, I think, the habits. I mean, you build those bad habits basically in uni, where you need to hack as quickly as possible so that you finish it, and then you go out into the world and you continue that. And if you have nobody that tells you, please stop, now we do software engineering, then you will continue until you get retired, and it's bad. That's the bad code afterwards.
Another thing is that they teach you to work alone, right? I mean, you should you are assigned to one project, you should do it alone, not together with the collaboration. So they treat coding as a loner activity, which is the least efficient way to write code, right? I mean, we should do it in pair, more programming in a team together. So yeah.
Yeah, and Kai, you even said it before that in the end, the other one wanted you to work alone. So you basically learned that, well, in the end, I have to do it alone anyway. So I will do that.
My experience, maybe other people had different experiences, but that's what I learned.
Same experience, really. Same experience 30 years later.
Okay, there are 2 comments about this argument from Welcome. By the way, welcome. Good to see you here as always. Fully agree for not talking about clean excellence to the business. It appears overkill for them, luxurious.
That's a great word. I love that phrasing, right?
Exactly. And he has an additional point about this, talking about accidental complication versus essential complication is far better than saying clean. Yeah.
So, I'm not yes and is what I would say to that. I am concerned that even that is too much, right? When I talk to my business leaders, they're interested in dollars. Accidental complication, essential complication. Why does this matter? Talk to me about money. And so I agree that accidental and essential complication is better than clean, but I don't know that it takes us far enough in the direction of really communicating to business folks on what we are selling, what we are saying. Hey, look, I can make it cheaper to build your code. It's more expensive for 2 to 6 weeks, and then it's cheaper somewhere between 6 and 13 weeks. That's what I'm selling. That's always what I'm selling. And when I make it more complicated than that, I have found it less effective. That is Kyle's experience. That is not everybody's experience. Maybe other people will find different things. But I've spent a lot of time narrowing and simplifying messages. Code can be cheaper to change. That's it. That's what I got. I mean, 25 years to learn to say that one thing is not very impressive, but
it's like poetry, you know. I find a shortened way of saying it. So we can, I guess, classify this as associated with audiences. So for the business people, ultimately, it's about cost. This thing about, I mean, accidental versus essential complexity. Okay, I guess this could be relevant maybe for talking to developer audiences. The way the relationship that I see between this and cost, and why this might be more useful than the word clean, is because if we want to optimize cost, we would like that, I mean, okay, essential complexity, we have to have it. But accidental complexity, we would like to have it close to zero. So if someone is able to achieve their design of the architecture, whatever, to reduce accidental complexity, then they have minimized total cost to the minimal. So it's about actually minimizing accidental complexity is the overall goal, not clean code. But I guess this is still up for developer audiences.
Okay, let's jump to the next question. Sorry, I cannot pronounce his name. Just an idea for thinking. What if you can take a look on yourself career, not just like an employee who works on a company, but as a professional who sells his knowledge to concrete company? Kyle, what is your take on this, or what are your first thoughts about this?
My first thoughts was I lived in Russia in 1996, so that's Ilya, right?
Ilya. Thank you very much. I appreciate it. Very good.
After that, honestly, that is my career. I have been independent for almost my entire career. I have been a traveling consultant. I go from one place to another. Somewhere in 97, 98, I went, wait a minute. Making code that's easy to change is the big deal, but I didn't have it in very good words. And so 98 to 2023, that's been my career. I have been trying to help organizations get better at making future code changes cheaper. That's what I do, and that's how I do it. I have been much more formal about it. I've been independent. I've been a consultant. I've been somebody calls me and says, hey, Kyle, I have your kind of problem. Will you come help me? Will you come help me for a week, or will you come help me for a few years? Or I'd like to hire you until we don't have this problem, or something like that. But it's all, so that's how I have been approaching it. I think that's a great way to approach it. I would love to spend an hour talking about the economics of how you think about your career in comparison to a company and what trade-offs you need to make. But I don't think that's about this. So yes, that's how I think about it, Ilya. I think it's a good approach. I'm going to stop talking.
All right. If there are no other points from us, then I jump on to the next question. It looks like a juicy one. Let's look at it from Alina. What are your experiences with the word quality? Is there a need to replace this one with a more business-friendly word, same as replacing clean code?
So I love that question. That's one of my favorite questions. It's a really, really big deal. Nobody knows what they mean when they say quality, right? Some people use quality to mean the group of people who does tests, right? Some people think quality has a lot to do with NFRs or performance or security or something. Other people use the word quality. I think we use the word quality to mean, hey, this is good code, it's excellent, it's technical. I don't have the problem specifically with the word quality from a everybody knows that they're supposed to like quality and so they're in favor. The problem is they don't know what they're talking about when they say quality. And so I find it tremendously valued to be super clear when I say quality. I mean, I want to make this code better by making it cheaper to change. I want to make the code better by decreasing the bug count. I want to make the code better by making sure we don't have securities. And when I say quality, I just don't find that we have alignment on what it means. So yes, like clean or good architecture, I don't use the word a lot, but it's because we have 7 different meanings of the word, and I would encourage you to be precise in your meaning. Not that quality isn't a decent word, it's just there's 6 meanings and 1 word.
And the other thing I think is when you talk to business and tell them, well, I want to introduce more quality, aren't they like, well, what were you doing until now? Like, I don't get quality. I mean, it costs a lot, but no quality. Okay.
Indeed, it's a vague term. Huh? It's also versatile, so it can have a lot of forms or meanings. Therefore, we can fail at communicating with this. I totally agree.
Exactly, and another issue also with the word high quality. So if you tell someone, would you like a high quality, the business people might say, so sorry, I don't want high quality. I'm fine with normal quality or like medium quality.
How much does it cost?
Yeah.
Okay, there is one point. It's not a question, rather just an argument or opinion from Diego. Let's look at it. When I sell a TDD training, I usually talk about how much will cost them any change or how much money will they save in bug fixing, not about how beautiful will their code will be. That's useless. True.
I mean, it's good if we're talking to us, right? But yes, essentially. I would love also to hear critiques of my particular framing. I'm arguing a very strong point here. Technical excellence means cheaper to change code. I personally think it helps us even as developers to think that way. Hey, is this actually making it cheaper to change for the future? Or am I gold plating? Right? There's a lot of people who are used to the words technical debt, and they say, oh, but we can carry some technical debt. And they're used to the words better code, but they say, oh, we're gold plating it. We don't need it to be that good. And so from my point of view, even when I'm deciding what I want to do, I have shifted my attention. Does this make it cheaper to change? Can I reasonably expect that if I take that stupid if clause out and replace it with polymorphism, then we're going to have better code. It is going to be easier to change moving forward.
That's a good point. And
you will probably also take into account how readable is it, because I mean the introducing polymorphism part is usually where it gets not so readable anymore. So that's probably also the gold plating part. Looks cool, but it's very hard to read for the first user that looks into the code.
Well, and it's interesting. I bet that because you're the only three people I see, I bet that if I took an if statement and replaced it with polymorphism, we would go, yeah, that's cleaner. It's easier. If it comes forward, I will have an easier time changing it. Right? However, if somebody's a new developer who's a year out of school, maybe that's not true. I find schools teach what polymorphism is, but never what you should do with it. So, right, you also have to pay attention for understandability on the audience. If I'm dealing with new devs, I don't use a lot of ternary operators because they can't read them. If I'm coding with y'all, I go, oh, ternary operator, that's the easiest way to do this one. Right? It's cheaper than the 4 lines I would have to do if I had to separate it.
So would you always stay in the I mean the problem then is you always stay in the lowest quality possible, so that the developer with the lowest skills can understand your code, right?
So the lowest reasonable person who would be on this project, right? If I'm with a team and we're mobbing or pairing, the skill levels go up remarkably quickly. And so I don't have to worry about that. And 3 weeks later, I mean, I've been known, I have paired with interns coming out of school, and they didn't have me doing anything exciting. So I paired with my intern friend a lot. And I swear she was the best architect, attentive person on the team in like 6 weeks, because we spent a lot of time pairing, doing things together, thinking about things together, and going, oh no, that's not how you want to think about this problem. And so upskilling via pairing or mobbing is so fast and easy. So many stories of, yes, we got an intern, and at the end of the summer, people not on the team were calling her a senior developer because she learned so much by the pairing or mobbing or whatever. Right? So, yes, but.
But this is so important. I mean, this upscaling. I mean, if you go to business and you tell them, well, we are going to pair or mob, they're like, what? No, parallelize. I want to parallelize. Yeah, but you don't understand. Everybody is going to be better afterwards. You get more afterwards.
I am. So the weirdest thing about pairing with this, like, intern, she's not done with college yet. She's joining us. We're hanging out. My code gets better. That's the thing that keeps pissing me off. I got 25 years of dev experience. Why do I get better code when I pair with a teenager?
Yeah, they can challenge the foundations. That's what I experienced with working with junior, by the way, that they can really challenge the foundation. They can ask really deep questions, like really basic questions, but we would never think about that because it's so normal for us. But okay, he or she asked this question. Okay, I need to explain why, what. So they challenge these things. I really like working with them personally. There is one more point here from Diego. Let's put it on the screen. Diego, of course, business people thinks about business, and the software that we make supports a business. That's why they look scared when they talk about clean, elegant, or nice code. Bang on.
Yeah. So I have a question. Can I have my slides back? I want to move back to a couple slides and see if we have thoughts. Back up 2 or 3 slides. This is the one I wanted to go to. What do you think? Software is cheaper to change. Is that what these are doing?
That's a good question. That you are interested in various arguments. I would say like this. Coming back, I would actually start off, since this is a technical group, definition of quality. Maintainability is one aspect of quality. And of course, there's others like performance, security, etc. So I like to use that IEEE classification system of quality, which is the only official one that I'm currently aware of. So the way that I currently see it is, okay, maintainability is one of them. And it so happens that maintainability happens to be particularly relevant to enterprise businesses where that seems to be a key concern. So I would say the statement about technical excellence is about, making, let's say, software cheaper to change. I would say the aspects of technical excellence associated with increasing maintainability characteristic are the ones that make it cheaper to change. So I like to segment it there. Now, since you did talk about the ethos and the polymorphism, I find that a nice example because that is often used in a lot of the debates. And there have been certain criticisms whereby people have said, if you just follow Uncle Bob, like the statement is no more if statements, do polymorphism everywhere. So some people take even that interpretation, and that's where I find if clean code has a certain rule and you follow it, but you're not thinking about is it minimizing cost. That's why I think it's better, as you suggested, think about is this minimizing cost. So if I have one if statement, like only one if statement, and I also can't predict the future either, and then I introduce polymorphism instead of that one if statement, I've now added an additional interface. I now have to jump into two classes, and I have actually no indication that in the future that there is even no need for polymorphic behavior. Then in that case, I would say that I increased the cost of change. Whereby if maybe I wait for another if statement and another if statement, and I see, okay, I'm projecting that in the future these if statements will grow, then I can say, okay, I'm doing this to decrease cost of change. What I found, because I saw the word like patterns there, that sometimes patterns can increase cost of change and that they are introduced prematurely. I myself have done that in the past. So that's an example of accidental complexity. So that's like lessons learned. Now, hexagonal and clean architecture. I would say hexagonal for me personally exists just due to testability, and testability happens to be a key ingredient in maintainability. So that one is like clear yes associated with maintainability. Clean architecture, I see it as a derivative of hexagonal architecture with just more higher level of specification regarding layers. So I see a similar answer. Refactoring, changing code so that it's more maintainable. So I see it again. Maintainability. Devops is an interesting one. I actually have no comment on that. That I see it as a wider topic. And extreme programming, I would say a lot of the practices like test-driven development, continuous integration, that they are associated with maintainability. And the people who came up with TDD and clean code are also, like Uncle Bob, the whole group, Martin Fowler, that it is all about increasing maintainability and decreasing cost of change. So for me, all of those words are clear, except just the DevOps one. I find it broader. That's from my side.
Thank you. Right, I always like to have a different person think at me with.
I have one question. Where is the domain? I'm missing the metaphor of extreme programming here, like, or the focus on the domain, like domain-driven design. I think this makes code more readable and the mental mapping between business and the developers much smaller.
So I have a super thing that I would love to talk about. I'm worried that I'm out of time. One of my favorite things ever is watching the debate over TDD between Uncle Bob and the other guy who I love, James Copeland. When I watched that, I watched 45 minutes of two human beings completely failing to communicate. Right? I love both of them, but they're both super smart guys, and they missed completely. My personal argument is it has to do with the split between object-oriented analysis and object-oriented design that happened sometime in the late 90s around the time of extreme programming. And the object-oriented analysis people went one way towards domain-driven design, and the whole business, James Copeland's favorite example about a bank account is really a sequence of transactions. It is not a name and account number and things like that. And that actually makes a difference for your ability to change stuff in the future. But the pro-analysis folks and the pro-design make it cheaper to change folks went in very different directions, and really the hexagonal architecture stuff in the last 6 or 7 years is really the first time they've come back together and started talking effectively. So I think that part's super exciting, but I'm out of time. So I want to.
Personally, I can only agree with this, with both of them. So yeah, Kyle, what a pleasure! It was an amazing session. We loved all of us. Thank you very much. We appreciate it. We thank you for your time. We enjoyed pretty much. Also, thanks a lot for Valentina and Oliver. And we were Tech Excellence. Learn how to deliver quality faster. Yeah, this is a slide sheet. So we are available online. You can find us on this platform. And for the next session in 2 weeks, we prepared for very, very exciting one. So stay tuned. Thank you, everyone. And again, Kyle, thanks a lot. It was a great pleasure.
Thank you all for letting me come play.
Thanks a lot.
Thank you.
Thank you all. Bye-bye.
Bye-bye.